Hello everyone. I hope everybody gave the contest of Atcoder yesterday. How many of you gave the contest yesterday, the 531? You can just give thumbs up or write in the chat. So I hope everybody gave the contest. Even if you haven't gave the contest, you have seen the questions, you have tried to observe the questions. So today we are going to discuss about the two contests that held yesterday, and the first we'll discuss about the Atcoder contest. So let's start. I'm going to share my screen. Just give a thumbs up if you can see my screen. I hope everyone can see my screen. Am I audible? Okay. Are you able to see my screen? Okay, fine. So we are going to discuss about the contest. So let's see. This was the contest that of Atcoder that we had yesterday. And let's start with the first question. The first question was Hell World. We can see the time limit is 2 seconds. So let's read the question. The question states, you are given an integer x between 1 and 10 inclusive. Output the string obtained by deleting only the x character from the string hello world. So hello world is a string of 10 characters and you have to input a integer x which will give the position of the character to be deleted from the string. So this is very like this has nothing. This is a really easy question. So what we need to do here is we'll just input the x and then we'll use a built-in function of C++ that is string.erase, s.erase, where we give two arguments. One is the position and another is the number of characters to be deleted. It is really easy. I'll just show you the code and you can understand whatever is the thing. So this is the answer. So what you need to do is just see some examples and you just clarify what it wants to say. So the first sample input is 5. So what is the fifth character? We can see HELLO. So there was a O which is the fifth character. So when we delete the O from the string, we need to print the output that is hell word. Now again we have sample input 2 where we have to input x which is 9 and we have to delete the ninth character. So what is the ninth character? That is L, hello world. L is the ninth character. So we'll just delete L from here and we need to output that. And then we have the sample input 3 where we'll take the integer x value as 1 and we'll delete h. So this is the code. We are taking integer x, we are taking input of the integer and then we are creating the string that is hello world and then we are using the built-in function. Now why these are the two arguments of the function. One is the x minus 1 which is the position here and another is the number of characters. Now we have to delete only one character and here we need to specify the position of the character. Now why are we using x minus 1 and not x? Because it is given in one index. So we need to use 0 index because strings are 0 index, right? But here it is specified in one index. So we'll just shift the position by 1. So we are giving the position as x minus 1 and we have to delete only one character. So s dot erase x minus 1 and then one character we need to delete and then we can just print the output string. So this is a very easy question, but just remember in the worst case, the time complexity of s dot erase is big O of n. That's it. Though we have to delete only one character here, but in the worst case, it takes big O of n. Now let's move on to the second question. I hope everybody understood the first question, right? If you have any doubt, you can just ask. Just give a thumbs up if you understood, and if not, then I'll move on to the next question. Okay, so fine. So now we are moving on to the second question. So let's read the question. You are given n strings s1, s2, s3, so on till sn, which consist of lowercase English letters. So just try to keep in mind these things, lowercase, uppercase. You will just forget and do mistakes when you are doing the code. So it consists of only lowercase English letters. So n, we have to output what it's saying is define n digits c1, c2 till cn as follows. If the first character of si, so any of the strings, the first character of it, if it's one of a, b, or c, then we need to add 2 to our answer. Like add in the sense, not like digits add, like we need to create a string answer. So what, let's see what's the output is. We have to output a string, so we have to make a string with the add the character 2, append the character 2. If the first character of any string is one of a, b, or c, then we need to append character 2 in our answer. If the first character of any string is D, E, or F, then we have to append 3. If the first character is G, H, I, then we have to append 4. So this is the just stated what we need to do. I hope you understand the question, right? Let me explain it once again. So we'll take input strings. This is the input format. First we'll take n, and then we will take n strings s1, s2 till sn. Now we'll check the first character of every string. If the first character is one of A, B, or C, then we need to append 2 in our answer. If the first character is D, E, or F, we need to append 3 in our answer. If the first character is G, H, I, we need to append 4 in our answer. So the question only states what we need to do. So we just need to follow whatever it says and it will just pass. So let's see the constants. It gives n is less than 10 and we have time 2 seconds. So it's enough. We can just apply any brute force. Although it is really easy, we can just do it in big of n. Let's see the sample inputs. So here n is 2. That means we'll take 2 strings. One of the string is algorithm and another string is heuristic. Now what we need to do is check the first character of the string 1. That is A. Now A lies in this range, in between A, B, and C. So we need to append 2 to our answer. So the first character of our answer is 2. Now the second string is heuristic, whose first character is age. Now age lies in which range? See, GHI. When the character is any one of GHI, we need to append 4 in our answer. So then after 2, we are adding 4. So the final answer is 2, 4, 24. Now, so although this is a string, we need to output a string. Now the second sample input is n is 3. That means we'll take 3 words. One is I, one is love, and third is you. So for I, in which category it lies? GHI. So we need to append 4 to our answer. So first is 4. Then for love, the first character is L. So what we need to append in this, just see here, for L we need to append 5. So we are appending 5 after 4. Then the third string is U. So for U, the first character is Y, and for Y we need to append 9. So we are outputting 4, 5, 9. So this is very easy. We just do whatever the question states and the answer will be there. So let's see. So this is the code. So what we are doing is, first we are declaring n, then we are taking input of n, then we are creating a string which is an empty string which will be our answer. Now we are iterating from 0 to n. In each iteration, at first we are taking a string input and then we are taking the first character of the string. Now if the first character is greater than equals to A and less than equals to C, that means either A or B or C, then we'll just append 2 in our answer. I hope you can see that 2 is added as a character and not as a digit. So we are not adding like plus 2. Like if the previous character is 4, we are not going to do it 6. We'll just do 4 2. So we are adding 2 as a character. Now if the range is character C is greater than equals D and character C is less than equals F, then we will append 3. We have just did whatever the question stated in which range what we need to append to our answer, and at last we have printed the answer. So this you can see the time complexity we are taking iterating for n time, so the n time complexity, and then we are taking input and then we are doing just if else, which is just big O of 1. So it's the time complexity is big O of n. I hope everybody understood the question. I hope there is no doubt, and I hope everybody did this question. These two questions. These were really easy. Can I get a thumbs up if you understood the question? So we'll move on to the next. Okay, so now Subrojit will make you understand the next two questions.
Hello. Is my screen visible and am I audible? Just put a thumbs up. Okay, so let us start with question C and question D from the Atcoder contest. This question, both question D, I think I felt it was even easier than question C. Question C is a bit on the tougher side than generally what is asked in C. Can you tell me if you have approached this question during the contest? Anyone? Alisha, Ananya, Wasim? If you have approached this question, tell your basic or brute force approach. Okay, so let me start with giving you an overview of the question. Okay, so what the question tells is, suppose you have n cells. Okay, there is a row. You initially have n cells in it, and all the cells have zero number of blocks in it. Now you have two types of operations to be done. One is a type 1 operation, one is a type 2 operation. How is type 1 operation represented? It is represented as 1 and x. This 1 is the type, and for x, that is what it tells, that at x index in the what it tells that at x index in this row, increase the amount of blocks by 1. Okay, and what does the type 2 operation tells me? The type 2 operations is represented as 2 and k. It tells me that in this entire array, tell me how many such blocks are there who have how many such what do I say, indices are there or cells are there who have blocks greater than of at least k number of blocks. That is either k or more than k number of blocks. Fine. So how do we answer this question? Anyone? Mrityunjay, I think you have attended the contest. Do you have a brute force approach for this?
Yes, so yeah, I was thinking that we have to create a vector and then uh, for each query, I mean, it will be like time complexity big O n into q. So
Yes, absolutely. So I think what you want to tell is suppose in this array, see this type of instruction has a very important extra note with it, that incrementing at index x is a O of 1 operation. So it is not a problem. What the problem is, what is given here, it is told that if all the cells in the array have at least one block, then we need to decrement one block from each of the cell. So this decrementing from each of the cell will take O of n time complexity. And for q queries, if we do this O of n time complexity, the complexity will be O of q into n. Now q is 3 into 10 to the power 5. At max, n is also 3 into 10 to the power 5. So it reaches 10 to the power 10, which will give TM. So was this your approach?
yes, Bhaiya.
Yeah. Did you think how can we optimize this, or you didn't get any idea of that?
Sorry, Bhaiya, didn't get any idea.
Yeah, nothing to be sorry about. So let me tell this question. Listen to it carefully because it has a lot of parts it can be divided into. So what we can do is, suppose this, let us consider this array as A. Now it is very important to decide what does array of I store. Normally, in this case, in the TLE case, what we were thinking, that we will store the actual number of blocks that is there at index I. But we might not always need that. Let us do one thing. Let us store that how many increments happened at this index. Means this type 1 operations, how many times did we do on index I? Along with this, let us keep another variable. In my code, I have named that variable as full. What will this variable tell me? It will tell me how many times this array has become full according to this node. That means every index has got at least one block. Why am I keeping this as a global value? Because you see that when my array is becoming full with at least one block in every cell, I do not need to reduce one from a part of the array. I need to reduce one from the entire array itself. And if I need to reduce it from the entire array itself, that means this is a global decrement to the array, not a particular decrement. Hence, what I can do, that I can store it in a variable. Then, what I can tell is that if someone asks me at any moment that at index I, actually how many blocks are present, you tell me. Then I'll tell him that the actual number of blocks is A of I minus full, which means the number of times I incremented in total minus how many times the entire array was decremented by 1, because that many times only its value was decremented. Is this portion clear or not?
So, Bhaiya, can you repeat it once again?
Yes, let me repeat it. Suppose what we are doing, suppose we have a index in this array that we are keeping, where you were trying to go and then decrement all the values. At that one index, what we were normally thinking in the brute force approach, that if I get a type 1 operation, I will do a +1. If everyone becomes full, there will be a -1 here, and I will have the count of actually how many blocks are there at this index. Am I right? This is the brute force one.
Yes.
Now, what I am telling you that this the minus one thing we will not do every time. We will just increment a of I whenever we get a type 1 operation. But in another variable named full, we will keep a check that if my array is becoming such that every cell has at least one block, then in that case, I need to decrement minus one from all the cells, right? So rather than decrementing it instantly, let me store it in a variable that I will do full plus plus. That means once I know that I have decremented the entire array, I will not do it physically, I'll just store it somewhere. Okay, this concept is known as lazy updation. This is used in many places that let me be lazy. I do not need to decrement all the values instantly when it becomes full. Because suppose this index, we are reducing it 10 times. But actually in the query type 2 query, we have never been asked about this index. Then why do we need to decrement it always? That is why what we are doing, that we are considering that every time we will increment the value of a of I, that means a of x, that's some index that we will be given in type 1 query. And if the array ever becomes full, we will increment this full variable. And we will know that yes, one increment has happened on the entire array. That means, suppose if 3 times the entire array has been decremented till now, then and a of I stores all the increment that has been done till now, then a of I minus full will give the actual number of blocks that are currently there, that all the times I have incremented minus how many times I have decremented the entire array. Am I clear now on this?
Yes, we are.
Okay. So we are on the same track now. Let's go ahead. This is one idea is completed. Okay. So now I will talk later about how will I know that when I need to increment this full. For knowing this, I need to keep another vector. What will be that vector? In my code, I have named that vector as more. What will this more vector store? That is the question now. This more vector will store that how many indices. This was our row with so many cells. Out of this, how many indices are such that they have at least, suppose this is more. Okay. Now, more has its own indices, J1, J2, J3, J4. So, suppose more of K. More of K will tell me how many indices in my row, in this row, has number of blocks at least K. Okay. Count of cells which have at least K number of blocks will be stored in this more vector. Now, here also a very important point comes that then I think maybe O of n times we need to traverse this more vector to update it whenever needed. But no, you see, suppose let me give you an example that in the array A, suppose this third index, currently it has 4 blocks. Okay, so this third index is contributing in at least 4 blocks. That means in my more array at 4, the count will be 1. That index 3 is contributing 4 blocks. Now, if a type 1 operation comes and tells me that at index 3 you increment a value, so this becomes 5. Now index 3 has 5 blocks. Now what I need to change in more vector, what I need to do is in more of 5, I need to do a plus plus. Why? That means one block has come which is now contributing at least 5 number of blocks. But do I need to change this one? No, because if it is contributing 5 blocks, it is obviously contributing 4 blocks, 3 blocks, 2 blocks, and 1 block. So we never need to increment or decrement anything at the back of this array. Whenever we increment, I will come to an overall summary that I will understand how this entire flow is going on. At this moment, what you need to understand is our move vector is storing how many cells are there who are contributing to at least k values, k blocks. Means they have at least k blocks. Fine. I mean, do you have a rough idea? Even if it is not clear, I'll come to the summary. Can you get a rough idea of what I'm storing in mode?
Yes, Bhaiya.
Okay. So let's go forward. Now let us come whenever we get a type 1 query. Suppose we got a type 1 query. What we will do now? That is, we have got 1 and we have got x. So what we will know that before the incrementation, this is before case, okay? We have not incremented till now. A of x will have d number of blocks currently, okay? Now I have incremented the value because it is a type 1 operation. So I have done a of x plus plus, and now in a of x we have b plus 1 blocks. Fine, this is done. Now you can understand one thing, that up to this moment, before incrementation, this index x was contributing to at least how many blocks? At least b blocks. This index x had at least b blocks in it. So more of b had the count of this index. But the moment I incremented, what happened? Now this index is contributing to more of b plus 1 also. Because this b plus number of 1 blocks is now being contributed by index x also. That means whenever I'm incrementing this value, I also need to do another simple operation. That is more of a of x plus plus. That a of x, that is, we have got a new contributor. Who is contributing? I do not need to think. I have got a new contributor to this much number of blocks. That is b plus number of blocks. This is all we need to do in type 1 operation. But I have told you one more thing, that we need to check in every type 1 operation if our array is becoming full or not. Now you ask me, how do we check that if our array is full or not? For this, we need to go and O of 1 traversal. No, we will not do that. We have the more vector. This will tell me everything. Because what did I tell you? What is the actual number of blocks? It is a of I minus full. And this type 1 operation, what does it tell me? That every cell must have at least 1 block. That means for every I, a of I minus full should be greater than equals to 1. That means the actual number of blocks at every cell should be greater than equals to 1. Now, if I change the inequality on this side, then a of I should be greater than equals to full plus 1. Now see, what does this tell? This tells that a of I is contributing to at least full plus 1 number of blocks. So what do I need to check? That if more of full plus 1 is equals to n. This is a very important check. What does this tell me? It tells me that are all the n cells a contributor of full plus 1 number of blocks? If yes, that means currently all the cells have block at least. Because where did I get this inequality from? From this inequality. And what that does this inequality means? This means the actual number of blocks at every index is at least 1. So if we do this check, and if this check is true, then we will do full plus plus. And if we can get all this, I know it's a lot for a type C question. Like you have a layer of thinking in this. You need to think in layers for this question, but the concept is very important. Even if you are missing some point when you write the code, you will understand it slowly when you write it on your own. And this is a very important concept. The lazy updation concept is used in a lot of CodeForces question. Many question you'll see. Okay, so it is a very important concept. And after understanding this, the type 2 query is nothing, because our type 2 query is more vector itself. What does type 2 query ask? Tell me how many cells are there which has at least k number of blocks, and our more vector is itself that. Like, tell me how many number of cells have at least k number of blocks. So all we need to do is return more of k. Then what we can see, that this question, which generally when we see a query type 1, type 2, segment tree comes in our mind, pelvic tree comes in our mind, this is nothing but these are O of 1 operations. This updation, this full plus plus, A of x plus plus, more of A of x plus plus, these are all O of 1 operations. That means our question is now transformed, that the time complexity is O of Q, number of queries. Because for each query, we just need O of 1 operations. We do not even need to traverse the entire array. And yes, the space complexity, you can take it as O of n. But see, this is such a great improvement. You didn't even need to think about if n log n will work or not, if log n will work or not. These are O of 1 queries. So, am I clear with this question?
Yes, Vaya.
Okay, so if we are on the same track on this question, let me just fast show you the code of this question, because we need to go to the next question also. See, absolutely what I have told, I have done here. Let's see, initially, this one, can you understand? Mode of 0 is n. Okay, can someone tell me what does it represent? Mode of 0 equals to n. Why I have done this?
Means 0 blocks is contributed by all the n cells.
Absolutely correct. Because in the starting, all the blocks have 0, all the cells have 0 blocks. So initially, mode of 0 is n. Absolutely correct. And then, as I have told, in type 1 operation, we are seeing at what index do we need to increment? We increment at that index. Now, the mode it is contributing at that index, we increment it, and we check, is my array, is all the indices have blocks 1 at least? If yes, we do our full plus plus, that is a global decrement. And what we do in type 2 operation, we do more of x plus full. Okay, now can you tell me why I have done more of x plus full, not more of x in case of type 2? Okay, so if you can't see, actually, well, if you don't write the equation, suddenly you cannot see that. See, actual number of blocks is A of I minus full, right? And what do you want? This is greater than equals to k. That means A of I is greater than equals to k plus full. This k is only x that we have got taken as input. So what does this equation represent like before? Are all my, means tell me how many blocks are contributing to the amount, how many cells are contributing to k plus full number of blocks, that is x plus full number of blocks. Fine. That is why we have done this. So I hope this question is fine. Also, you can think it in this way. Suppose that I need how many cells have contributed to 10 blocks. but already 4 times global decrement I have done. That means I actually need to answer how many blocks are there who have contribution of more than 14 blocks, because they are already decremented 4 times. Then we will get the actual answer of more than 10 blocks. Is it clear?
Yes, Bhaiya.
Okay. So let us go to question number D. And I'm telling you, this question C took so much time. Question D will take half of its time. It is a very easy thing. Okay, means not too easy, but yeah, this question is easy. Let me give you an overview of the question. Question is also very simple to understand. What does it tell? It is, we are told that we have a string. Okay, suppose we have any string. From this string, we need to take all the characters and place them in such a way that no two adjacent characters are same. Okay, no two adjacent characters are same. And if it is not possible, we'll reply as no. As simple as that. The question is very simple to understand. Did you approach this question during the contest, or after seeing C, you have not even gone to D?
Yeah, I have tried and I approached like this. I have stored the counts of every characters, and then
Okay.
the maximum occurring characters should be uh, the I mean as like zeroth index, 2th index, 4th, and index like this
Yeah.
means the like this I have approached.
Yes. Did your code get accepted?
No, no, the I have not done this,
You have
but I have
approached it
thought like
absolutely
this.
correctly, but then why did you not code it? Like, did you didn't get the implementation at that time?
Then I thought that the other characters, how it will be implemented, and like between the two, the most occurring characters, how I will implement the other characters like this. So I didn't. Uh,
Okay, so your approach was, it is good that you approached the question and you thought about that case, that it will go to 4. This is the best case for the maximum occurring character. And actually, this is the entire crux of the question. All that was left in your approach was implementing it. So let me just tell you some formal terms about it. Have you heard about pigeonhole principle?
yes, we are.
Can you tell?
N
You can use
n
simple
number
words, no problem. In Hindi or English, anything is better.
like n number of pigeons, and there is like the number of, I think I lost the statement. But
Yeah, no,
what
don't need
is
the
that?
statement, just a basic idea.
Like uh, one pigeon. Sorry, I'm confused.
Okay, no issues, no issues. I'm telling you that how it is given, that suppose there are k number of holes, okay, for the pigeons, and you have k plus 1 same type of pigeons, then you are sure that there will be one such hole where there will be two pigeons of the same type. Am I right? This is the one you knew as pigeon hole, right?
Yes, yes.
Yeah. So, how do this idea come into play in this question? You see that as you have told, the most problematic character is the one with the max frequency, right? So, suppose we have this many blanks in our string to place all the characters. Fine. That is our here n is equals to 9. Now, we can consider this as our holes for the pigeons. Okay. And this character, suppose this character is X, this character be the pigeons and these are the holes. Now, to make sure that they are not adjacent to each other, in the best case, what we can do, we can place X here, 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 and here on the even indices, keeping one gap. Correct?
Yes, Bhaiya.
Right. If the max frequency of a character becomes greater than n plus 1 by 2, then we can never place them without making sure that they will be beside each other. Because we have n plus 1 by 2 number of safe holes. See, these are actually the safe holes, maximum number of safe holes to place the pigeons. Now, even if we have one more pigeon, one more than n plus 1 by 2, then within these holes, in one of the holes, we will need to place this character X. And the moment we place this, then this condition becomes false. That means the only condition for non-feasibility is if the maximum frequency of any character is greater than n plus 1 by 2, which is actually the seal of n by 2. In competitive programming, try to use seal as less as possible. Okay. So this one, if this happens, then we will directly answer as no. In all other cases, we can surely place the elements. Why? Because in the worst case, what will happen? That max frequency element will take all these places, and you will have some more elements left. Now you can surely, even if you have like this, you can place it. You can, if you have 3 elements, you can place like this. So no matter what, once you have placed X in all the possible even, means the maximum frequency in all the possible even indices, others you can fill in the gap very easily. Now the main thing is implementation. This was the entire idea of the question. Nothing else. The most problematic character, the maximum frequency one, and choosing even index for that. Fine. Let me show you the implementation, and you will be clear with everything. Is the logic clear? And you have also thought something similar, right?
Yes, yes, Bhaiya.
Okay. So now see the implementation. How I have done the implementation. That I hope it is visible. Let me zoom it. Okay. So we have a. Is it visible? The code is visible, I guess.
Yes.
Okay. So we have kept a vector. I have kept a vector of pair storing the frequency. That is, this will give me the frequency of the character, and this will be the character whose frequency I am storing. Keep one thing in mind, that whenever you are working with these alphabets from A to Z, there is no need of keeping an unordered map or a map. Okay, because only 26 are there, so a vector is enough in that case. Now, what I am doing, I am looping through the entire thing, and this one I'm just initializing that every character initially has the count 0. Now I am traversing through the given S, the string that I have, and I'm incrementing its count. Fine. Now what I have done, these are all reverse all. It is defined as in above in my template. So what it does is sorts the array in descending order. Okay. So if the array is sorted in descending order, what does it mean? The character with the maximum frequency will be at the front. Okay, which is our most notorious character. Now, this is our plausibility check. That if the character with the maximum frequency, his count is greater than n plus 1 by 2, then I'll tell no, I cannot do any kind of combination for which I'll get the condition satisfied. Else, I'm sure I can do. Let me print yes. Now let me store the answer. My implementation might be some smaller implementation is there. I have done it this way. It is very easy to understand. I have kept a answer vector which will store characters. See what I am doing. I have kept a index I equals to 0. Okay. I am going through all the characters, that is j from 0 to 26, till the frequency of that character. Means first, I'm starting with the maximum character because I've sorted in descending order. Till the frequency is greater than 0, what I'm doing, ignore this line. Come here. What I'm doing, answer of I is frequency of j dot second. That means at 0th index, I is initially 0. I am placing that character, this character, whose frequency I have in my hand. I am reducing its frequency and I am doing I plus equals to 2. That means I'll go to the even indexes only. 0, then 2, then 4, then 6, and so on. Now you may ask, why this check? What does it tell? That while going through the even frequencies, if I reach n, suppose I have the frequency as, I mean the length of my answer as 9. Now I'm traversing. I have placed at 0th index 0, then I have placed at 2, 4, 6, 8. Now I have got to 10th index. 10th index is not there in my array. What I'll do, I will instantly initialize I with 1. That means now I plus equals to 2 will help me travel in all the odd indexes. Now I'll go like 1, 3, 5, 7. So how my iterator, that I, is going 0, 2, 4, 6, 8, 1, 3, 5, 7. See, I have covered all the indexes that I have. And while covering all the indexes, I'm just placing the value there and reducing its frequency. Then I'm keeping a string T. I'm taking out each of the string from my answer vector and just adding it to T. And I'm returning T as my answer. Is the implementation clear?
Yes.
Yeah, so like this, this is a good trick that how you can change in the middle, like you can do one more thing. Because you know that the maximum frequency element will all, as I've told you, will always finish before you end the traversing the entire array. Means at max it will go till this. So for the maximum element, you can keep one single loop. Okay. And you can place that. And then start a new loop to place the other elements. So like for even indices, you can keep one loop. For odd indices, you can keep other loop. But this is a good trick that in one loop only you are just changing. Whenever I am reaching the end of the array, I'm coming to the odd indices. Okay. So this is the discussion about question C and D. These were really important questions. Do code this out on your own because implementation in such questions is very important. Let me just give you an overall summary, a very short summary for this question. Question C, what was important? The important was what I am storing in A of I. This equation, what I am storing in mode, and this inequality, writing the inequality. Okay, and time complexity. Time complexity is always important. And in this one, what was the only important thing? One is PGN hole and getting the idea about the even indices. And this one. That's it. Okay. So let us complete the discussion of Atcoder here. Now, after this, Aman will start with the discussion of the CodeForces rounds. Okay. So that's it.
Am I audible to you guys? If yes, then give me thumbs up. So let's start the yesterday's contest of CodeForces. So this is the first question. There are n slimes on a line where slimes I is at position AI on the line. You will perform the following operation some number of times, and what you have to do, you just have to select an integer x. Then for each j in between 1 to n, you will have to, if that element is less than x, then what you will do, you just increase less than x, then you will increase by 1. If it is equals to x, then you will not do anything, and if it is greater than x, then you will decrease it by 1. So you just have to tell them that minimum number of operations to make all slimes occupy the same position. So it's a very easy question, the example is given to you. If 1 2 3 4 5 is there, then your answer will be 2, because you can select 3, because you can select 3, and one and every element, if in array, because it whatever elements is given to you, it doesn't depends on the all of the elements. It's only depends on the first, it's only depends on the minimum element and the maximum element. Let me tell you why. uh, so so I'm telling you, like, this is your code, but I'm just going to explain you by the code. So here I have taken the all of the inputs, and now I'm telling you, explaining you this code. So you have to choose. So what you will do first, you will choose an element x in such a way that whatever will be your minimum element and whatever will be your maximum element in the array, this x will be in the uh, middle point of the a and b. Like, if it will be in the middle point or the nearer to the middle point, then a and b will end up to the x in the minimal operation. Let's say this is your example. To Like, the minimum, if there is a vector, but in that vector your minimum element is 2 and the maximum element is 6, and we don't really need to know the middle element, what are those. So but let's take this. These are the x values that we can take: x equal to 2, x equal to 3, x equals to 4, x equal to 5, x equals to 6. But let me tell you, if you will choose 4, then this will then 2 will end up to 4 and 6 will end up to 4 in the minimal time. Like, if 4 is in between or not in between, it doesn't matter. But what you will do, whatever element is less than x, what you will do, you will increase it by 1, and whatever element is greater than 6, what you will do, you will just decrease it by 1. So the 2 and 6 will end up together to the 4. So at this point of state, you will have the minimum operation that you have to require to convert all of the element to the x. And if, let's say, because both are even, let's say there is not 6, there is 7 at the largest element of the vector. So in this, what you can do, if x equals to 4, then in one operation the minimal element will come to 3 and your maximum element will decrease it by 1, so it will be 6. Now maximum element will be here, minimum element will be here, and maximum element will be here. And again, in one operation, 3 will come to the 4, and 6 will come to the 5. But you know what, that 2 that that 2 will that is that whatever was your minimal element, that is completed to 4, but your maximum element is 7. Now it is only 5. So you will again run your one operation again, so that will decrease it by 1, so it will again come to the 4. So in this way, your total operation will be equals to 3, and at this point of state, you can say that that your answer is minimum, and your total operation that you have to answer is your minimum. So what you can do, you just have to find the minimum element of the array and the maximum element of the array. And what you can do, uh, you just take the middle element. And why you have done +1 because you can see plus by adding +1 you can get the final answer, or otherwise you just have to take the CL value of maximum minus minimum divided by 2. So this is your first question, and if you guys have understood, then give me a thumbs up, or if you have any doubts, then you can ask. So let's move on to the next question, and this question is you find yourself with two arrays of positive integers a and b, and both of length n. You are to perform the following operation any number of times, and what you have to do: select an integer I and swap ai and bi. But keep in mind that indices is same of the both of the vectors. So, and what you have to answer, you just have to answer the maximum element of the this function. So you know what, you have to first observe the function, that what you are doing in the function. So see, you can all you have to add all of the elements uh, of the vector bi, and what you can do, if whatever will be the maximum element in the vector a, if you can swap to the minimum element of the vector b, then you will be able to get the maximum element in for each position. For each ith position, you will have the maximum element in the array bi, and because you have to add all of the elements, that's why you are doing this. Okay, so because you have to add all of the elements in B array, that's why you will maximize this part. And how you can do this: if you will, if whatever will be the aith value and whatever will be the bis value, if aith is greater than bis, then you will swap. Why you are swapping? Just to maximize this part, and you will be able to maximize it by swapping the maximum element from a to b. And whatever will be the remaining in a, whatever will be the remaining elements in a, you just have to take the maximum of that remaining array of a, and whatever, and these two part, whatever will be the these two part, you just have to add it and return it as your answer. So let's see the code of this question. And here you are taking the inputs. This is your A array and B array, and here you are swapping. If AI is greater than BI, then you are swapping the elements, and you are swapping the elements, and by this you are maximizing vector B, and then you have you have made a variable maxi, and whatever will be the maximum element of the ath A array, you will keep that element in the maxi, and you have, I mean, you just have initialized it. You just have initialized the maxi again with the maximum element of the array A, and then whatever will be the changed array, then whatever will be the changed array b, you will just add all of the element in the maxi, and you just have to return it as your answer. So this is your b question, and if you would have understand it completely, then uh, give it a thumbs up, or you can ask if you have any doubts. Do you guys have any doubts regarding these questions? Hello, hello. Am I audible to you guys? Is there any doubts? So let's move on, and And from the next questions, the Aman will continue. So that's.
Hello guys, I hope I am audible to everyone. I hope my screen is visible to everyone. Just give a thumbs up if it is visible. Okay, so till now we have discussed question number first and question number second. Now we will be discussing question C1 and C2, which are two subparts of a same problem. The first one is easy version and second one is hard version. So let me discuss this question. So in this question, you are given an array A of length n with and all the elements in this array are non-zero. Let me go through the docs in which I have summarized questions for you. Like in this question, you are given an array A of length n and all the elements are non-zero elements. And in this question, you can do an operation at most 10 times. And basically what you can do in one operation is you can select an index I such that ei is greater than 0. Keep this in mind, you can select only that index whose element is positive. And for each index j is less than equal to I, we can invert the sign of elements from 0th index to ith index. I mean, if it is positive, then we can change its sign to negative and vice versa. And after doing this operation for at most n times, we need to minimize the sum of our array, and we need to return sequence of operations by which we can minimize sum of array. So I would like to know if any one of you has tried this question on, or do you have any approach which you thought during the contest? Like any one of you can open your mic and tell. Okay, so let me discuss this question. So what is the minimum value we can get if we can change sign of every element? So that is, if we convert every element to negative, then we can do we can change and minimize the sum of array. If we change every element to the negative, then the answer will be minus of summation of absolute sum of all the elements, right? But here, as we can do this operation and change the elements if ei is greater than 0. So we will try to make all the array elements negative. Let's see how we can do this. So let me take a test case. Like I have taken a test case here of elements. Here are 9 elements. And what we are trying to do is we are trying to make every element negative so that our sum will be minimized and we can return a sequence of operations. So we will look it from right side. As you can observe one thing, that if we do one operation at a single element, so the elements which lies right side of it will not change. Like if we do operation on this index, then the elements which lies to the right of it will not change, and the elements which lies from 0 to ith index will reverse its sign, right? So as we want to make every element negative, so we will not touch these elements which are already negative on right hand side. And if we want to make this element negative, so we can do one operation, that this is I is equal to 7th index. So what we can do is we can use one operation here by selecting this index, and so these two elements will now become negative, as you can see here. And these elements will also, the sign of these elements will reverse. So after using operation at I is equal to 7, which is the at first positive element from right hand side, we have converted these 4 elements negative, right? So the elements which were previously negative, that is -5, -7, and -18, has now become positive. So till now, what we have done is we have converted all the elements, last 4 elements negative, and now we don't need to test these elements as we have already minimized this. And now, if we want to minimize this part also, then we can now do the same operation. We can use an operation at element 18, and if we use operation here, then these 3 elements will become negative, and this will become -5, -7, and -18, and the sign of these elements will become positive. So this will become 3 and 4. So after this operation, we have made all the elements after second index. Okay. So next thing we need to do is we can do these elements also negative. So you can easily see that we can also use one more operation at I is equal to 1 index, and I am saying that there is zero based indexing. So if we use another operation here, so it will be easily become negative. So after doing such sequence of operation, all the elements will become negative. So in similar manner, we can follow such a greedy approach of converting all the elements to negative. Let me show you one more test case. So in this test case, as all the elements are already negative, so sum is already minimum, so we can return it as it is without doing any operation. And in this array, as these 4 elements are negative and this element is positive, but we want to also make it negative. So what we can do is we will start iterating from right hand side, and if we encounter first positive element, then we will apply one operation at it. Suppose here if we apply operation at 4, as it is our first positive element from right hand side, then this will become 4, and this 4 operation will become, these 4 elements will become positive. So after doing that, okay, let me show you the code so that it will be more clear for you. We are following the approach to convert all the elements negative. What I have done in my code is, let me show you. See, I am storing in an answer vector the sequence of operations in which we will use the operation. I will store index of operations, and here as I am storing and my array as 0 based indexing, but in answer it has been said that we need to use our array with 1 based indexing. So we will keep this in mind. And here I have taken a positive variable. It means at first we are searching for a positive element for applying the operation. And here you can see I am running a loop from starting from last element to first element, that is from right hand side. And if we encounter, firstly, if we encounter a positive element and POS is equal to truth, it means we are searching for positive elements. So if from right hand side we encounter a positive element, then we can do an operation at this index, and we can store this index. I have stored I plus 1 because in the question it is given that we need to return answer based on 1 based indexing, but I have used 0 based indexing array. And once we have used operation on that positive element, so thereafter we will search a negative element. Now you will ask that we can't use operation at a negative element, but after performing this, the elements which are negative on left hand side will become positive. That's why I am searching for a negative element. And again we will move towards left hand side, and if we encounter a negative element and in false, if it is stored false, it means we are searching for negative element. So this part will also be true, and thus we can apply an operation on that element. And again we will make false is equal to true. It means after applying an operation on this element, we will again search on positive element. So we will keep doing operations like this and convert all the numbers in our array negative so that it can minimize the sum. So this was a simple greedy approach, and at last I have just printed answer.size, which means the number of operations, and this is the sequence of operations. So I hope this question is clear to everyone. If any one of you has any doubt, then you can ask. Or you can or give a thumbs up if you have understood this question. Okay, so let's move on to next question. Just wait a minute. So let's move on to the C2 question, which is the hard version of this problem. Just wait a second. Okay, so this is the hard version of the problem, and in easy version, we were needed to minimize the sum of array A at the end, but in this version, we need to maximize the sum. And here, everything is same as that of previous question. Like in this question also, we can do this operation. So we can select an index I such that A is greater than 0, and we can change for each index j such that j is less than equal to I. We can invert the size of elements from 0th index to ith index. So the operations are same. We just need to maximize the answer in this case. So let's see how we can do this. If you will observe, then let me go through the docs. So if you will observe that if you apply operation on the and on right hand side, nothing will change and everything and sign will flip on its left hand side only, as I told you this observation in previous question also. So I am assuming that what if we applied only last index. This is the last index on which we have applied the operation. What if this is the last index on which we have applied the operation? So the elements which are right to it will remain as it is, right? And the elements which lies left of it, if you will observe, then we can make all these elements negative by using the same procedure we followed in previous question. What I mean to say is, let's do a dry run for this example. Suppose this is the array and we are assuming that 5 is the last index. I mean, this is the last index on which we are using the operation. So the elements which lies to the right of it will remain unchanged, and the elements which lies left of it, we can make all these elements negative using the same procedure that we followed in previous question. Let me tell you how we can make all this negative. So what we can do is, as these two are already negative, so just leave it as it is, and we can use an operation here as it will become negative. So all these 4 elements have become negative, and thereafter what we can do is, as I am supposing that this is the last index where I am using the last operation. So what I can do is I can use an operation here, and it is easy to see that these all elements which were negative will now be flipped and become positive. And as this current element was positive, so now it will become negative, right? So this was the observation. Like for every element, we can check, and by supposing that this is the last index at which we are doing the operation. So on right hand side of it, rest of the elements which are on right will not change, and the elements which are lying on the left hand side, we can make it negative. Let me show you one more example. Like this is an example, and if I am supposing that 8 is the last index at which I'm applying the operation. So what I can do is, this is the last index at which I am applying the operation. So right hand side will not change and remain as it is. And for left hand side, which is this, we can make all these elements negative using the same procedure as we did in previous question. So we can make these elements negative by, as these are already negative, these three elements, and this we can make these two elements negative by using one operation at -7. So it will become -8 and -7, and then we can again use an operation at 10 and 4, as -4 will be operation at -7. So we can make all these elements negative, and thereafter, after using operation at, after making all the elements negative, we can use operation at index 8, and we will be able to convert all these elements positive, and the current element will become negative. In the similar way, we can, for every index, if we are supposing that what we need, how can we implement this? So what we need is, we need to we need to calculate previous all absolute sum of all the previous elements. Suppose I am at this index, so we need to calculate the sum of all these elements, absolute sum, because we will make it positive later on after using the operations, and we need to count the sum of all these elements. So for doing this faster, in just big of one, we can use the concept of prefix sum. I hope you have studied the concept of prefix sum. So for finding sum of elements from I plus 1th index to n minus index, we can use the prefix sum. Let me show how implementation works here for this. Just wait a minute. So what we can do is, like, firstly, we can make a prefix sum vector, and initially at 0, I'm using the array as 0th index. So prefix of 0 will obviously be the first element, and then this is the loop which I've used for making prefix sum vector from the given vector, in which prefix of I is denoting the sum of elements up to ith index, and it is obviously, and we have already calculated the prefix of I minus 1, which is sum of element at up to I minus 1th index, and if we add v of I, so this combined will give prefix of I, which means sum of element up to the ith index. So after making prefix sum, with, I have taken a sum variable in which I will store the absolute value from 0th element to I minus 1th element. And then suppose if all the elements are negative, all the elements are already positive, so we don't need to do any operations. So for this, I have made a maximum variable in which we will store the maximum possible answer after doing operations on each index. So if we don't do any operation, so our answer will exactly be sum of the elements in the given array. So it will be prefix of n minus 1, as it will store sum of whole array. And this is the IDX. It will store when we use last operation at a given index, so which index will give the maximum value. So we can, I am iterating from first index to last index, and if, and as we can apply the operation only on positive elements, so I am considering only for positive elements, and you can see here I am storing in sum the absolute value for up to, I have done this, I have adding in sum after this if condition. So when we are using sum here, so it will store the sum, absolute sum up to 0 to I minus 1th element. So if v of I is greater than 0, then what I am doing here is, this is what we can make the sum if we are supposing that we are using this is the last index at which we are using the operation. So so as our sum has stored the absolute sum from 0 to I minus 1th element, so we will use, we can count this in our answer, and as our current element is positive, so it will become negative. So this is the sum minus v of I, and the elements which are lying right hand side of current index will be as it is. So we can calculate sum of this from prefix sum vector, and this will give sum from I plus 1th element to n minus 1th element, as we are subtracting from pre of n minus 1 to pre of I. So all the sum from all the numbers from 0 to ith element will be cancelled out, and it will give sum from I plus 1th element to n minus 1th element. So this is what we can make if we are supposing that this is the last index at which we are using the operation, and if this current is greater than maximum, so we are storing it in maximum and we are updating the index, and at last our index will store the index where we are getting the maximum value. So after doing this, suppose if my index has not been updated and it is still -1, it means our original array was good and it was giving the maximum value. So in this case, we don't need to do any operation. So just print 0 and give a space. Else, if we find any index by which we can maximize the array, so what we can do is we will use the same procedure as we used in previous question. In previous question, we were making all the elements negative from 0 to n minus 1th element, but here, as we want to make negative of only up to idx minus 1th index, so I am using the same loop but from idx minus 1, and this is the same code which I used in previous question. So what I did from this is I have made from 0 to idx minus 1 elements all negative from doing these operations, and I have stored in answer the sequence of operations. And after doing this, after making all the elements from 0 to I minus 1th index negative, we will again do our operation at index idx as I have to return in one-based indexing. That's why I am storing idx plus 1. So if we do operation at idx, so it will convert idx to negative, and all the elements from which were this from 0 to I minus 1th element is positive. So after doing this, I am just returning the answer.size, which is the number of operations we have used, and this is the sequence of operations we have used. So I hope this question is clear to everyone. If you guys have any doubt, then you can ask. Or just give a thumbs up if this question is clear. Okay, so that was all about yesterday's CodeForces contest, and as we have completed our discussion, so you guys may leave the meet.